The ICEVI, the Nippon Foundation Mathematics Package for Teachers video series, Abacus as a Mathematical Tool. Title of the video, Double Digit Divisor and 5-Digit Dividend. Example, 55,555 divided by 44. Let us take another set of fancy numbers, that is 55,555 divided by 44. Let us set the dividend 55555 on the right extreme of the abacus and set the divisor 44 in the left extreme of the abacus. As 4 is less than 5, let us set the quotient by skipping a column to the immediate left of the dividend. As there is 1 4 in 5, we cannot reduce it further, and therefore 1 is set as the assumed quotient. Let us multiply 1 with 4, that is 0 4. That means 0 subtracted from the 100,000s column and 4 subtracted from the 10,000s column. That is, subtract 5 in the upper abacus and add 1 in the lower abacus. We have to multiply 1 with 4 again, that is 0 4. That means 0 is subtracted from the 10,000s column and 4 subtracted from the thousands column. We cannot do that, and therefore subtract 5 in the upper abacus and add 1 in the lower abacus in the thousands column. Now we are left with the dividend 11555. Let us take 4 and 11 and ask how many 4s in 11. By saying 2, let us reduce 1 and set the 1 to the immediate right of the quotient 1. Let us start the multiplication process. That is, 1 multiplied by 4 is 4. That is, we subtract 0 from the 10,000s column and 4 from the thousands column. We cannot do that, and therefore subtract 1 in the 10,000s column and add 6 in the thousands column. We again multiply 1 with 4, that is 0 4. That means 0 subtracted from the thousands column and 4 subtracted from the hundreds column. That is, clear 5 in the upper abacus and add 1 in the lower abacus. At this stage, we take the first 2 digits of the dividend, that is 71, which is larger than the divisor 44. Therefore, simply add 1 to the quotient and subtract 4 from 7 and 4 from the 1 in the hundreds column. So we can't do that and subtract 1 in the thousands column and add 6 in the hundreds column. Now the remaining dividend is 2755. Let us take 27 of the dividend. As there are 6 4s in 27, let us reduce 1 and set 5 as a part of the quotient. Let us multiply 5 with 4, which is 20. That is, subtract 2 in the thousands column and 0 in the hundreds column. Again, multiply 5 with 4, we get 20. That means subtract 2 in the hundreds column and 0 in the tens column. We note again that 55 is larger than 44, and therefore simply add 1 to the quotient and subtract 44 from the dividend. Now we are left with 115 in the dividend. Now ask how many 4s in 11? By saying 2, let us set 1 to the immediate right of the quotient. Now 1 is multiplied with 4, that is 0, 4. That is 0 subtracted from the hundreds column and 4 subtracted from the tens column. We can't do that, and therefore subtract 1 in the hundreds column and add 6 in the tens column. Let us multiply 1 with 4 again, that is 0, 4. That means 0 is subtracted in the tens column and 4 in the units column. That is, clear 5 in the upper abacus and add 1 in the lower abacus. Now we are left with the remainder 71. Now the remainder 71 is larger than the divisor 44, and therefore simply add 1 to the quotient and subtract 44 from 71. That is, 4 is subtracted in the tens column and we have to subtract 4 in the units column. We cannot subtract 4 there, and therefore subtract 1 in the tens column and add 6 in the units column. The answer we get from this problem is 1,262 as the quotient and 27 as the remainder. Even in a lengthy problem like this, involving fancy numbers, following the correct procedures will take us to the correct results.